Okay, let's do another limiting reactant practice problem here. So here's the situation. In a lab, 184.73 grams of aqueous lithium carbonate solution react with 403.35 grams of aqueous copper 2 chloride solution and 289.43 grams of some solid product are produced. And so this problem brings into account some of the solubility rules that we are familiar with by now, hopefully. And so that's the situation, and let's look at the types of questions you have to answer in this problem, okay? The first one is gonna always be this, right? The balanced equation. Then we're gonna determine the limiting reactant. We're going to use the solubility table to determine which of those products that gets produced is the solid, and then we're going to calculate the percent yield and percent error for the production of that, and then finally we're going to see how much of the excess reactant remains unreacted. Okay, so let's start right here with A. So write the balanced chemical equation. We're not writing the ionic equation here, we're going to write it out as we normally do. So here we have lithium carbonate, aqueous lithium carbonate. So that's lithium, LiCO3, and I guess we need the little two subscripts, the lithium. It's a +1 to a -2 oxidation ratio, and that's an aqueous solution. Okay, we're gonna react that with, here we go, copper 2 chloride. So that's Cu and Cl. This is a +2 to -1 ratio, so we need a subscript 2 here, and that's also an aqueous solution. And what we produce in a double replacement reaction will be lithium chloride, LiCl. This is a +1 to -1, so that's a good formula. And the other product is our copper 2 carbonate, so CuCO3. And that's a copper type 2 from the problem, and so that's a +2 to a -2 ratio. So that's all good. Now, we need to use the solubility table to determine which of these two products is our soluble and which is our solid product, because we're asking the questions about the solid product. So let's take a look at lithium chloride. So soluble. So here we see that group 1 ions, they are always in compounds that are soluble. So lithium chloride, this is our aqueous product. And then the copper 2 carbonate, let's just double check our carbonates here. So carbonates are insoluble typically. They are soluble when combined with lithium, sodium, potassium, ammonium, but copper is not an exception to that. So that's our solid product. Okay, so we're really asking the questions here about the copper 2 carbonate and not so much the lithium chloride. So let's go ahead and balance the equation now that we've got it written out here. So we'll do this just kind of quick. 2 lithiums, it looks like we need a 2 here. 2 lithiums, 2 lithiums, 1 carbonate, 1 carbonate, 1 copper, 1 copper, 2 chlorines, 2 chlorines. Good. So this is balanced with just the 1 coefficient here on the lithium chloride. So that's going to make things easy for us. Okay, balanced equation, done. Limiting reactants. So here we're going to compare again our two reactants to each other. We're going to define one of them as A and one of them as B and determine how much of B gets used up along with all of the A. So again, I'm going to use the first one in line as A. So, the first thing you should do after this is write down your molar masses, of course. I've got that for you. 73.84, copper chloride, 134.45. And then I'm going to not do lithium chloride because it's not in the problem. But copper carbonate is 123.56. Okay, so now that we've got those numbers in place, we can use them to determine the limiting reactant. So I'm going to, again, select this first compound, lithium carbonate, to be A. And let's go ahead and do the math here. So we start with 184. 0.73 grams of lithium carbonate. It's got a molar mass of 73.84, 1 mole. Mole ratio here between A and B is a 1-to-1 ratio. That's nice. And then the molar mass for chemical B is 134.45. Okay, let's do this math here. 184.73 times 1 times 1 times 134.45 divided by 73.84. Okay, 336.36. And that's grams of chemical B, which is copper 2 chloride, CuCl2. Now we got to determine which of these two reactants is in short supply. So we got back to the problem, and we have been given 403 plus some grams of copper chloride, and it's only going to take 330 grams of it. So that's nice. Much less is required than has been given. That means our chemical A is our limiting reactant. So lithium carbonate is our limiting reactant. Cool. Okay, so Li2CO3 is limiting. Okay, that means that when we go through and look at the production of our product, we're going to base the production of our copper carbonate on the amount of lithium carbonate we have to work with. Okay. Oh, use the solubility table to determine which product is solid. We actually already did that, and we determined that the copper carbonate is our solid. Okay. So maybe a little out of order in how those questions would be asked. Okay, now what is the percent yield and percent error for the production of that solid product? So here we have to, when we find a percent yield and percent error, we've got to work with a theoretical value, and then we can compare it to an actual value that has been given to us in the problem. So let's figure out how much of that copper chloride should be produced theoretically. So again, we base that production on our limiting reactant, which we've defined as lithium carbonate, of which we have 184 grams of to use. So 184.73 with a molar mass of 73.84. The mole ratio between our limiting reactant and our compound in question is a 1-to-1 ratio. And the molar mass of the solid compound, 123.56. Okay, so this calculation here is going to give us our theoretical value for the production of copper 2 chloride. Excuse me, copper 2 carbonate. So 184.73 times 1 times 1 times 123 point divided by 73.84 gives us 309.12, and that's grams of copper 2 carbonate produced. Okay, so that's our theoretical yield. Okay, now what we want to do now is do our percent yield. So we're going to take our actual over the theoretical and then multiply that fraction by 100. And that looks like this. Our actual production given to us in the problem is this number here, 289.43. And then we theoretically should have produced 309.12. Multiply that fraction by 100. 289.43 divided by times Okay, that's a 93.63 0% yield. So we produced pretty close to all of what we should have produced. We produced 93% of what we should have produced. And then our percent error is, again, just the difference between the actual and the theoretical. I'm going to do the bigger number first, 309.12 minus 289.43. Divide that difference by the theoretical here, 309.12, times it by 100. Okay, let's do the math here. Minus 289, 19.69 divided by 309.12 times 100. Okay, that is a 6.36% error. Okay, so there we go. We've got our percent yield and our percent error calculated. Okay. All right, and then finally the last question that we do here is how many grams of the excess reactant remain unreacted? So again, we have determined that lithium carbonate is our limiting reactant, so it's all going to get used up along with some portion of our given copper 2 chloride. So let's just figure out how much gets used. And actually, luckily what we've done is we've actually done this problem in the determination of our limiting reactant. And it can work out this way sometimes. So here I would be doing this same exact dimensional analysis problem right here. And so what we're doing is looking at the entire amount of limiting reactant that's going to get used up, and we're going to see how much of the copper 2 chloride makes that happen. And that is lucky that we've actually already done that here. So we have used up 336 grams of the copper 2 chloride. So we've started with 403 grams. So 403.35 grams that we started with, minus the amount that we used, which we calculated to be this number, 336.36. And the difference will be the amount of that copper 2 chloride that remains unreacted. So let's just take the difference. And that gives us 66.99. And that's grams of CuCl2 left over. All right. Okay. So a lot of work goes into these problems, and there's a lot of things you can do wrong. Anyway, I hope this example helps you.